Okay, skewed data. Skewed data is data that is not symmetric. It's not evenly distributed. It kind of gets pulled in one direction or another. For instance, I'm a football fan of the Jets, and right now the Jets have so many injuries, and they're calling up lots of players that are super young from the practice squad, that it's skewing the data and making the data look younger than it normally would be if all of the regular players were not hurt and were healthy for the team. So do you see how this one on figure 2.17, you see how it's kind of got more places on the left, and then figure 2.18, it reverses it and puts more on the right. This is what normal symmetric data would look like. And in the symmetric data, the mean, the median, and the mode are all equal. The mode is the most popular one, so that's going to be the highest bar in this particular histogram. The median is the one in the middle, and because everything is perfectly symmetrical, the middle is going to stay the middle. But if we went back here, you can see that with things not being symmetrical, the middle is not a dead middle of a graph, as it is here, or of a histogram. And lastly, the mean, whatever it works out to be, in this case it would be 7, is because everything balances. There's the same number of 6s and 8s, the same number of 5s and 9s, and the same number of 4s and 10s. Meaning that the mean, the median, and the mode are all going to be the same. And we're kind of working our way toward this thing called a normal curve. Okay. Now, let's talk about a skewed to the left distribution. Basically, when there are more scores creeping out to the left, kind of pulling the information to the left, making sure that there's more columns on the left, if you will, more bars on the left than there is in the center, then that would be that you're skewing it to the left. Just like those young players made the team look younger by putting in more values to the left and less values to the right, that makes it skew to the left. When it skews to the left, the mean is going to be less than the median, which will be less than the mode normally. We're not 100% sure about the mode, but normally speaking, it would be. If we started with the typical graph, which looks like this, basically what we're doing is we're taking some of the scores on the right here and we're either getting rid of them or we're moving them to the left-hand side. When that happens, we used to have this column where everything was even with each other and everything was symmetric. Now that's not the case. What's happening is this score of 4 here, these extra scores put out to the left, you notice there's not as many 8s to balance the 6s, and there's extra scores at 4 and 5. That's going to pull that data to the left. It's going to distribute it. The further you go to the left and the more scores there are to the left, that lowers the mean because you're adding in scores that are smaller and smaller when you do your calculation. Imagine, if you will, that the mean of 4 scores was 100,000 and then you sold several houses for $10,000 each. Isn't the average or mean value going to go down? So that's why we know that the mean will be less than the median, which is the middle. As we go to the left, the middle gets pulled a little bit this way. The average gets pulled fast. The median doesn't get pulled quite as fast, but it does get pulled. And the one that's probably going to be, but doesn't necessarily have to be, is the mode. So here's what we remember. When you go to the left, things become less than. Just remember the typical order: mean, median, mode. That's the order you've learned it in your entire life: mean, median, mode. And when you go to the left, you go less. Okay? What if you skew to the right? If you skew to the right, now instead of getting extra scores on the left-hand side of the graph, you start getting extra scores on the right-hand side of the graph. And when you go to the right, it's going to be greater than, and both greater than and right have an R in them, okay? So it's still mean, median, mode, but this time we're going to go greater, okay? Mode and median tend to be closer to the middle than the mean does. So that's why the mean is greater than the median is greater than the mode. So let's give you an example of how all these things can relate to each other. Statistics are used to compare and sometimes identify authors. The following list shows a simple random sample that compares the letter counts for 3 authors. Make a dot plot for the 3 authors and compare their shapes. Calculate the mean for each and the median for each. And then describe any pattern you notice between the shape and the measures of the center. Okay, do that now and then we'll show you the answers. So it's a stop and start time. Okay, now here's our answers. First off, Terry's box plot, Davy's box plot, and Mari's box plot. The one that looks the most symmetric is going to be, it says down, Maris. This says Mari's and this says Maris. I don't understand why. Terry's mean is 3.7. And look, this means there's 1 1, there's 2 2s, there's 3 3s, 1 4, 1 7, and 1 9. So I just do 1 plus 2 plus 2 plus 3 plus 3 plus 3 plus 3, or just plus 12 because 3 times 4. Plus 4 plus 7 plus 9. Add them up, divide by how many there are, and that gives you the mean. Terry's is 3.7. Davis's is 2.7. Okay? And Maris or whatever that's supposed to be, Mari's, is 4.6. Now, calculate. Oh, we did the dot plot, then we calculated the mean. Next up, calculate the median for each. Terry's median is 3, Davis' median is 3, and Maris's median is 4. Describe any pattern you notice between the shape and the values. Okay, so it appears the median is always closest to the high point. So keep in mind, 3.7 and Terry's median was 3. Davis was 2.7, the median was 3. Maris was 4.6 and the median was 4. So in each case, the median is closer to the high point, which is the mode, because the mode is the most frequent and the high point is always going to pull data toward it because there's most of those. So there's 4 3s here. There's 1, 2, 3, 4, 5 3s here. And over here, there's modes of 4 and 6. So the median is going to get pulled toward the mode, and that's because when there's so many mode ones, like if we take a look at Davy's letter, there's 5 3s. So that's going to cover a big chunk of scores, and the median is likely to be really close to it, okay? In a symmetrical distribution, the mean and the median are both centrally located and really close to the high point. All right, so that's how we can count some medians and some modes, and we can look at some skewing. In Terry's letter count, we're skewed to the right. In Davy's letter count, we're skewed to the left a little bit. And in Mari's letter count, we're slightly to the left, but it's pretty close to symmetric. Okay? All right, so that covers it for today. We got a sense of when we look at figures, if we see skewed to the left or skewed to the right. They're skewed to the left, right? Extra scores to the left-hand side, pulls data to the left, and pulls data to the right. It is skewed to the right. All right, so now we'll get started on a quiz to finish up today's lesson.